So the second speaker is Professor Hiroshi Uyama. His lecture topic will be bioplastic, and he's from Department of Applied Chemistry, Graduate School of Engineering in Osaka University. His research area and expertise consists of biomass plastic, research in porous nanomaterials, and functional bio-based polymers. So, without any further hesitation, we will ask Uyama Sensei to present his lecture. To Uyama Sensei, you can start now.
Okay.
For all participants, maybe you please mute your microphone during the lecture.
Okay, now the monitor changed to my slide.
Yes, we can see your screen.
Okay. Okay, now I start. Okay, so now, now some confusing the words. Okay, maybe okay.
Yes, please start.
Okay. Okay, so okay, so I will start my lecture. So my name is Hiroshi Uyama, and today I'm talking about bioplastics. So maybe so you know, um, so plastics now maybe some environmental benign issues. Then so today I'm talking about such as so background, and additionally, so I explain the bioplastics. Okay, at first I explain the background. So now most of the chemicals, including plastics, is obtained from petroleum resources. Maybe you know the fossil resources is produced for longer time. So in many cases, more than 10 million years. But so if we use chemicals or so after usage, in many cases, we burn such a chemical plastic, then carbon oxide release. Such a carbon dioxide is converted to biomass, then by photosynthesis. But anyway, so fossil resources production and the release, so this unbalance period is one of the reasons to increase the carbon dioxide amount in the earth. Then if we can change such a so starting material from fossil oil to biomass. In this case, so biomass carbon is produced for a very short time. Then we can recycle the sort of carbon resources. Then this is a, we call the carbon neutral concept. Anyway, so one possible way to reduce the carbon dioxide in the earth is so use a biomass for chemicals and plastics. So maybe you know you often see such a pictures, photos. So in many cases, so many plastic waste appear in the earth, especially in the ocean. Then such an ocean, in some cases, so damage to the some animals or fish. Then and this is a very tedious problem. And then so at first I want to demonstrate one movies. Okay, so this movie is one background for to protect the ocean from the plastic. And then today my main purpose is to demonstrate the bio-based plastics or biodegradable plastics. Then at first I explained the why we and the background of bio-based plastics. So at first I explained the biomass. Biomass is also a carbon resources in the earth. Then such a biomass is divided three parts. One is agro-based, the second one the lignocellulose, and the third one is the organic waste. Then such as so three categories is totally we call the biomass. Then in many cases such as so agro-based feedstock is mainly used, especially for starch. And because such a starch or sugar is very easy to convert as a biomass plastic starting material. And the lignocellulose is maybe the most important material because cellulose is the most abundant resources. But in some cases, cellulose is a highly crystalline material. They're not easy to convert such as bio-based plastics. And organic waste is, of course, so it is a very important issue, but also in many cases, not easy to separate the good carbon resources from waste. Then now it is just only underway to reuse or recycle such organic waste feedstocks. And this slide shows us land use for bioplastic. This means our earth is very big. Then in many cases global agriculture area is around 1/3. But also for industrial use is very small like this. Then especially bioplastics amount the too small, then at present maybe increase the production of the bioplastic, maybe no problem for land use, or also such as competition of the food. So this slide shows us how to produce a chemical or plastics. Now, most of the plastics produce oil-based, and additionally, production condition is also oil-based. Then today I'm focused on the biomass plastics, but unfortunately now, factory is acted by oil energy base. But for in near future, we should change the starting material as well as such as factory operation should be changed by using biomass, also recyclable energy, including such as sunlight or wind. So this slide shows the category of biomass plastics. So bioplastics mean two meaning. One is biomass plastics. The another is biodegradable plastic. For both cases, the first one is the bio, then we call that totally bioplastics. But the meaning much difference. Biomass plastics is just using the difference of starting material. This means fossil oil base or bio base. The biodegradable is the one material property, so strength or stretchable something. Then in this case, biodegradable or durable. Then all the plastic is divided 2 by 2, then all the 4 categories. Then today I focus on the biodegradable and the bio-based plastics. So lactic acid, something. Additionally, so in some biodegradable plastics, it produced from petroleum resources. For example, polybutyl adipate, something. Then recently, so some commercially available plastic, polyethylene or polyamide nylon, is bio-based. So this means, so maybe our understanding of the polyethylene or polypropylene is a fossil oil base. But recently, companies so developers so bio-based polyethylene or nylon. Okay, so this slide divided so the division and another standing point is naturally biodegradable and synthetic one and a non-synthetic but a non-biodegradable. So naturally biodegradable is so starch, cellulose, and the lignin, and this PHA is later I explain. Then polylactic acid, polybutylene succinate is also biodegradable plastic from bioresources. Then this caprolactone is a very famous biodegradable plastic monomer. It from petroleum resources. The ethylene or propylene, of course, also in many cases, so we obtained from fossil oil resources, but recently, so we can obtain from bioresources. This part I later explain. So this slide shows some focus on the SDGs for bioplastics and environmentally benign so plastics. Maybe you know the SDGs consider 17 goals. Then here I show the 8 goals. So in some case, so to protect the ocean or land means so such as recycling or biodegradable so protect so such as so earth environment. And additionally, so for example, so another topic also contributes to the bioplastics or biodegradable plastics. So this slide shows that sorry. Okay, I'm sorry. So I restart. So this slide shows us so I'm sorry. So now my screen not good. I'm sorry. Okay, so and this slide shows so biopolymer of plants. This means so lignocellulose consists of cellulose, hemicellulose, and lignin. The cellulose is the main material and highly crystalline. The hemicellulose and lignin is so a kind of so adhesive material for wood. And so this wood is so most abundant by resources, then we should use such a wood or some plant for production of a bioplastic. But in some cases, not easy. But anyway, this is a very important biomonomer or biopolymer resources. So I thought this slide very fine, so not easy to read, but this very important material. For example, so from sugar. So sugar easily produced by ethanol. So maybe you understand, so ethanol to easily to convert ethylene. This ethylene is so from bio, then bioethylene, then we can produce a biopolyethylene. Then ethylene is easily converted ethylene glycol. The ethylene glycol is also very important monomer for PET, polyethylene terephthalate. Additionally, so sugar is easily converted the lactic acid. This is a monomer for PLA, polylactic acid. Additionally, so oil for especially castor oil. Castor oil is so non-edible, very specific oil. But also this can be produced to convert it as a monomer for nylon. So nylon 14, 16, or nylon 11. Additionally, so oil is so consists of so glycerol and so highly fatty acid. Then glycerol is easily obtained from plant oil. Then glycerol is easily converted 1,4,1,3-propanediol. This is a monomer for PTT. PTT is also 1,3-propanediol terephthalate, trimethylene terephthalate. Additionally, so cellulose is also very important material for some bioplastic. Anyway, so sugar, including cellulose and the plant oil, is a very important material for production of bioplastics. This slide shows a typical example. Then corn means the starch origin, and the sugar cane, of course, are sucrose. And in some cases, such a plant is glucose fructose. And such as easily to convert by fermentation or chemical treatment to produce lactide, succinic acid, and this is very special, so furan and diacid. Then PLA and the PBS is also already commercially available as a biomass plastic or biodegradable plastic. Then this is also new plastic, new bio-based plastic. Now, so European country companies so now just so underway for industrialization. The later explained, so PHA is also biodegradable and biomass plastics. This from oil or for sugar by fermentation process. Then this slide shows that very important typical example of bioplastic biopolyester. So at the present, so biodegradable plastic in many cases such as aliphatic polyester. So the typical example, the PLA and the PHBH. PLA is so just so from lactic acid. Then this plastic shows us a highly brittle and very but highly transparent transparency appears. Then applied some plastics. Then PHBH is recently many people focus on the application because this polymer now one of the very important marine degradable plastics. Then this is a little soft and stretchable comparable PLA. Then this polymer is biosynthetic material. So this is some microorganisms. Then this white part is this just polymers. So this slide shows how to produce a PLA. PLA is so 3 steps. The first step is a photosynthesis from carbon dioxide to polysaccharide starch. Then starch is converted to enzyme treatment and fermentation to produce L-lactic acid. The important point is this L form or D form is required. So highly optically pure lactic acid is required for production of a good plastics. Then lactic acid is converted PLA, polylactic acid. Maybe if you have some fundamental knowledge of organic synthesis, so alcohol and carboxylic acid easily to convert it ester polymers, but unfortunately, this direct polycondensation is very, very difficult. So high energy and so high polymer cannot be obtained under conventional technique. Then now, commercialized process is so this 3 steps. At first, so produce oligomer, then for depolymerization to produce cyclic dimer. Cyclic dimer called a lactide. Then cyclic dimer is easy to polymerize. Then PLA with high molecular weight. And so two bioprocesses, photosynthesis and fermentation. Then finally, so chemical process, total 3 steps is required to produce a PLA. This slide shows some future of PLA. Here, so I call PLA is L form. So now commercial available PLA is L form. Then of course D form is okay, but so L and D is so different. So microorganisms require. Then now only L form is commercially available. The merit is so of course bio-based, and this transparency stiffness is so good future. Then PLA product is obtained from various molding processes. But many demerits so suppress the application of PLA. So honestly, maybe the property is not good. So impact resistance, some stability, or crystallization. It is very important so for injection molding. Then gas barrier property is also very bad. Then brittleness. Additionally, so recently, so PLA, so but that property so increase some application, especially so shale gas production. Then amount of the PLA is not insufficient. Then so prices increase. Then so now very expensive plastics. Okay, the second example, the PHA. So PHBH is one of the families. Then some microorganisms produce this PHA. So here I call P3HB, so poly R3 hydroxybutyrate. So some microorganisms produce this PHA polymers, so energy resources. Then additionally, so this is a very good biodegradability, but unfortunately, this polymer is, the property is not good. Then so many researchers tried to improve the property by some microorganisms, so modification. Then recently, one Japanese company, so Kaneka company now produce the PHBH, and this good biodegradability in ocean. And this photograph is also model products. So 2 years ago, so we have a G20 meeting at Osaka. Then Kaneka is also demonstrate some PHBH product in this meeting. Okay, next one is also BioPBS. PBS is from a butanediol and a biosuccinic acid. Then now so BioPBS means so previously this both from petroleum resources but also biodegradable. But recently so joint company of Thailand and Japan. So PTT is so Thailand company. MCC is a Mitsubishi Chemical. Mitsubishi Chemical is a Japanese company. Then this joint company developed so BioPBS. Then this polymer is so now only succinic acid bio-based. One from butadiol is so fortunately from a petroleum resource. But anyway, so this polymer showed very good biodegradability. And additionally, so this polymer is so the property itself is not so good, so a little soft material, but also mixing of PLA and PBS shows a very good physical property for some products, especially so thin film or something. Next one is a biopolyethylene. This is so developed so Braskem. Braskem is a Brazilian company. So this commercialized so nearly 10 years ago. Maybe you know so in Brazil so by ethanol produced a much amount, then so price is very low. Then Brazilian company so develop bioethylene from bioethanol from sugar cane. Then produce a polyethylene. This is so apparently the same from petroleum resources, but so honestly, so the resource is different. Then by using a biopolyethylene, so we can contribute to the so environmental protection and to suppress the so release of the carbon dioxide. So not only this company to produce, then unfortunately, so the production amount is not so enough. So now 200,000 tons per year in this company. For ethylene, so total amount maybe 8 million or 9 million ton per year in the world. And so this amount is very small, but so anyway, so this trial is very important to reduce so carbon dioxide amount in the earth. Then an important point is so petroleum resources based polyethylene, the bio-based polyethylene is the same. Then so application very easy. Then this is a typical example. So bottle. This is so just a cup noodle. Maybe you know the inside wrapping is most component is polyethylene. Then so cup noodle company, the Nissin, now uses biopolyethylene to protect such as paper cup for noodles. Okay, so another example is a BioPET. Then I already explained. So now, so from ethanol, so we can obtain the ethylene glycol from biomass. At present, most of the PET is produced ethylene glycol and the paraterephthalic acid. They both are from petroleum resources. Now, some of PET is produced bio-based ethylene glycol and the petroleum resources terephthalic acid. Then now some company now try to produce terephthalic acid from biomass. This is one example. So US venture company now try to commercialize so parakishilene from biomass. This is a fermented process. Then parakishilene is easy to convert it terephthalic acid, then produce a biopolyethylene. But this is only underway. Then additionally, so another US venture company now try to commercialize so just the same PX by recycling technique. This is also very important because PET bottle is easy to recycle them, but also recycling method is now insufficient for commercialization. Okay, so another important point is starch-based plastics. So now in the world, the most abundant resource is cellulose. The second one is starch. But the starch itself is not easy to produce plastic. But so mixing of biodegradable plastic and the starch produce good plastics. This is the one example. Matabi is so Italian company produce this plastic. This is just a blend, so starch and biodegradable plastics. Then additionally, of course, another polysaccharide is a very good candidate to produce biomass or bio-based plastics. Then this slide shows global production capacity. In this slide, so this orange is the biodegradable plastic, then green one is a non-biodegradable plastic. Then for the polylactic acid, PLA or PHA is biodegradable under bio-based material. In this case, including this orange part. Then anyway, so in the world, so total amount is gradually increase like this. Then additionally, so ratio is almost the same, but a little larger than the biodegradable plastics. This slide shows the market segments. So this means most of the bio-based plastic bioplastics is the largest share is the BioPET. The second is the bio-nylon and the biopolyethylene. Then also polylactic acid on PBT, petroleum resources biodegradable. And also biodegradable plastics amount not so much. And most of the share is non-biodegradable bio-based plastics. This is application. So this is very similar to the common plastics. And so plastics, the largest application is the flexi package. The second one, the rigid package. And so package is very important. Additionally, consumer goods something. Then, and so for such as single-use plastic is one reason to protect the environment us. So then, any such single-use plastic production should be reduced. Then, if we can obtain such as biodegradable plastics, maybe if one release the marine environment, but 1 or 2 years later, such as biodegradation occur, then any such as single-use application should be changed as such a new material, I think. Okay, so this is also bioplastic potential. This just a potential. This means this inside the circle is the present plastic share. Polyethylene is around the third. Polypropylene, the total polyethylene and polypropylene is almost half. Then additionally polyvinyl chloride or polystyrene. Then, but at present, honestly, we have no good candidate because BioPP or biopolyvinyl chloride, we have no good answer. This is only potential. So now biopolyethylene already available, but for replacement potential polyethylene use, many is biopolyethylene, but I just explained biopolyethylene capacity is very small. Then anyway, we should develop more production and more type of bioplastic at present. Okay, so I explained some example how to commercialized in such a material. So at first I explained so GreenPla is so biodegradable plastic. Then one of the most important applications is the multi-film. In this case, after usage, so such a hard work after harvesting, so biodegradation occur. Then no pot for transportation is also another example. Then additionally, so in US, so US and EU has a so compostable culture. Then after eating inside, then so such as so apparatus also so should be biodegradable in the same time. Then and such as so products should be biodegradable in US or EU. Okay, additionally, so biomass plastic application. So this is a little old, so any so computer body or this is a floor mat of car, and additionally, so old type phone something. In Japan, we registered the bioplastics mark. The register number one is so card, registered card, and it's produced by Dai Nippon Printing, so DNP. Then so this is a PLA product. Then another one is so shrinkable sleeve for PET bottle. So this around 10 years ago, so some company additionally drinking producer developers or shrinkable sleeve. Another example is a tray for salada. This transparency is a very important point. Additionally, so shoes for kids. In this case, so shoes in many cases, so soft material required. But so Kurare is Japanese chemical company, and the Moonstar is also shoes company. Then this collaboration produce so some brand something. Then PLA and the PET mix woven fibers, then produce also bioplastic shoes. Another example is also toy. This is also from the PLA. Another example is a wrap cutter, not wrap. So here, this in this case, this cutter is so plastics. Then such plastics from PLA. Then this is old example, but anyway, so in Japan, so some copy machine companies, Canon, Fuji Xerox, and Sharp, so develop so plastics parts from PLA, like this part. So Japanese mobile company also so use also bioplastic for car parts. For example, many parts from art or heating or some visor, something. Then so in many cases, PLA or also PET-based material. Then this also so driver seat cushion. The cushion is so just a plant oil, so castor oil based cushion for automobile application. Okay, so now finally I want to show the so some movies. Okay, so I want to say so this movie so prepared so student then so important point so um, maybe so like me the older person so had not good concept but so younger people had so very good concept for development of so bio-based or biodegradable plastics. So this is a very urgent issue to protect the global environment. Then so I hope so you have an interest in today's my lecture. Then so if you have interest, so please join my laboratory. So my laboratory studies bioplastic monoliths at the hydrogen. Additionally, so interest point is so my laboratory is around the half is so foreign student. Okay, thank you for kind attention.
Okay. Thank you, Professor Hiroshi Uyama. Now we will have a question and answer sessions. Sensei, in the chat room, we have 3 questions. So let me read one of the participants' question.
Okay.
From Helmi. Is it possible that there will be edible bioplastics? So it can also act as food reserve?
It's also very important point. So yeah, so in some persons so said so especially use so sugar starch, so maybe not good. Because so some maybe African company so lack of the food. But in some cases, so agricultural production, so for plastics, so helps so their economical power. Then so this is a very um, difficult and so sensitive problem. So then it's not easy to explain. But anyway, so such as edible material is very important for bioplastic production. So
Okay.
then so maybe we should discuss so in near future. So this is not only me. Okay. Okay. So
Yeah,
this is some question we obtain. So at first, so nanocellulose question. So nanocellulose is a very important, but so for unfortunately, so electronic material maybe not easy because so cellulose are the highly water absorbable property. So electric application, so water is strongly so inhibited. Then so this is the one find so cellulose application in electric devices. Now maybe so especially company person do not um, had a good, no good um, candidate for practical application. Of course, so some researcher in university so study, but so honestly, so nanocellulose is not good. I think this is my opinion. Then additionally, so edible, I answered. Sorry, so next one is so how to see that okay, so bioplastic from biomass are very, in some cases, so honestly, so especially LCA, so life cycle assessment, in some cases not good, and because so um, production for especially so the important point is so the property of the plastic is very important because so maybe you know so polyethylene and polypropylene show the very good property, but so unfortunately bio-based plastics the property is not good. This is one reason why bioplastics so practical application not so much. Then so of course so economical and efficient production is a very important point. But so now, so honestly, my laboratory mainly focus on the blending, not synthesis. This is my laboratory recently method to develop bioplastics. Okay.
Okay, thank you, Sensei. So we still have a time. Is there any question from other participants? Sensei, I would like to ask just curious. If I want to buy you show in the previous slide there is an example Asahi drinks using the bioplastic bottle. So
Yeah.
for one bottle of the Asahi drinks, so how much if you compare with the conventional plastic? I just want to know. So is it expensive, more expensive, or
No. The price is the same, but so this is so honestly, so the company use only small amount. This means so maybe less than 10% is used. Then we enjoy the inside, not the bottle. Okay, you understand? Then it's not easy to find such a bioplastics bottle in Japan.
I think because we have to convince our government to use the bioplastic for the production, because we already know that in Indonesia there are a lot of waste from plastics that can be harmful from for the animals inside the sea, and also the citizens of Indonesia, they don't care. They don't care about the bioplastics, such a thing. So if you have any recommendation for us how to convince our governments to maybe to reduce the waste plastics, something like that.
It's also very important. So now today I have no time to explain. So in Japan, so recently, so recycling is the maybe most important issue, especially some drink maker, because so PET bottle is so recycling is easy. So in Japan, but also real so applications such as recycled bottle is not easy. Then such as so recycling technology now maybe so we have a most important issue for urgent development. Of course, bioplastic also, but so such a recycling so maybe most important for us now.
Okay, maybe one more question from the Vidya Astuti. Is it possible that bioplastic can totally substitute plastic usage, and how to design and choose appropriate material for bioplastics? Sensei, please.
I'm sorry, I can't follow. Yes.
Is it possible that bioplastic can totally substitute plastic usage, and how to design?
My opinion, no. Yeah,
Oh.
because so now so polyethylene and polypropylene is so around half of the plastic production. Then property is very good and the price is low. But also now at the present, so similar plastic is not easy to obtain from the biomass. Then maybe maybe only the few percent is maybe maximum, I think. So total replacement and very difficult.
Okay. Well, thank you very much, Professor Hiroshi Uyama. Sensei, is it possible for us to see your video camera on?
Okay, sorry. So
Committee will take a picture of you. Okay, that's a charming.
now it's okay.
Okay, please, the Ms. Nurul, the committee, could you take a picture for Uyama Sensei?
Sorry. So now I cannot. Okay. Okay.
Okay. Mbak Nurul udah?
Yes.
Just a moment, Sensei.
Okay. Yeah. I have
Okay.
the picture.
Okay. Thank you, Professor Uyama. So, for the participants who interested in Professor Hiroshi Uyama, you may ask in his email. And also for a lecturer who are interested also in his research, you may start collaboration with Professor Hiroshi Uyama. Thank you very much for your participation, Professor Hiroshi Uyama. We will contact you for the next collaborations.
Okay, thank you very much.
Thank you very much.
Goodbye.
And goodbye. Thank you, Sensei.